Hello everyone, welcome to the Hench. Today we are going to solve another interesting problem. This is coming from LeetCode. This is going to be a bit challenging, but we will try to analyze and see how we can create an approach towards a problem and what are the steps that one should take before solving any given Java problem or before actually writing the code as a solution for the problem. Okay, so let's just try to understand the problem first that we have at our hand right now, and then we will try to make a human solution for this, and then we will try to write a code for that human solution. So every time the approach should be like one should understand the problem perfectly, try to analyze what exactly being asked so that we do not make mistakes on our solution, and then uh, try to find a human solution that as a human how you would get to a solution to this to the given problem. And third step would be to write a code for that solution or creating a code in terms of generic solution for that problem so that any input may come, that code works for all of them. So this is like a general programming is the same. Like we are given a solution, we try to find a human solution, and then we try to better our solution or maybe try to do the same solution in a generic way so that it works for each and every method. Okay, so let's just try to analyze this problem at our hand. Okay, so there is an array A of n integers. Okay, we would be given an array named A with an integer. There can be a number of n integers sorted in non-decreasing order. That means it will be sorted in an increasing order. Okay, in one move you can either remove an integer from A or insert an integer before or after any element of A. Okay, let's just understand this first line. We would be given an array of integers which will be sorted in ascending order. Non-descending means ascending order. In one move, okay, you can make moves in this array. You can either remove an integer. If you remove an integer, that will be one move, or insert an integer before or after any element you can insert. That will also be a one move. Okay, so what you can do in moves, either remove an integer from the array or add a new integer from array. Each will be counted as a one move. Okay, the goal is to achieve an array in which all values x that are present in array occur exactly x times. Okay, what is the goal? I mean, what would be the goal to make these moves? In by making these moves, we will project our array so that in which all the values x, say there are different x values that are present in array exactly x times. For example, yeah, let's go with the example. That means each element should be present the time. Occurrence should be same as that of digit. Example is coming up here, like given A, here we have 1 1 3 4 4. So 1 should be present only one time as per question, right? It is present two times. So you would have to remove, or like it only solution would be to remove, right? Next is 3. 3 you need 3 times, but it is present one time, so it is less in two numbers. So you need to add 3 two times. I mean, just for a solution, but we would have to make a solution. I mean, this is just for a solution for 3. Or either what you can do is remove 3, right? We can also perform remove operation, right? So you can add 2 times 3 to make it 3 comes 3 times, or you can remove 3 entirely so that it does not occur. And 4 is less one time, so it is also explaining same. Value 1 occurs twice, value 3 occurs once, and value 4 occurs 3 times. You can remove one occurrence of both 1 and 3. If you remove 1, that means 1 is fixed, and 3, if 3 is removed, then 3 is removed, no longer required, right? And insert 4 in that places, right? Okay, not in that place, like for a one can be removed, one say one got removed. Okay, 3 removed, 3 got removed. Now only problem is 3 times 4, just add 1 4 more. So this will result in 1 4 4 4 4. So 1 is present one time, 4 is present 4 times. This is the array that we need. Okay, I hope the problem is clear now. Let's see what more it has to say. in this array every element x occurs exactly x times. Okay, this is our goal. Every element should comes exactly the number of I mean the occurrence should be same as that of digit. Say for example digit is 1, it is occurring only one time. So digit is 4, it is occurring 4 times in an array. Okay, what is the minimum number of moves after which the value x array occurs exactly x times? Okay, we just have to give minimum number of moves that has to be made in order to get such array. Okay, I hope this should be clear. Let's move forward with what exactly it has. So it is something like, method has to be designed which accepts an integer array, right, and returns an integer. An integer should be the minimum number of moves, right? That given an array A returns the minimum number of moves after which every value x array occurs exactly x times. So we'll just have to design one method which accepts array as input and returns integer as output, which returns integer. That integer would be the minimum number of moves that should be made in order to get this thing done. Okay, let's just read more examples. This is the same example 1 1 3 4 4 4. So it's like minimum number of moves should be 3. What here? 1 2 2 2 5 5 5 8. Okay, so your function should return 4. It will explain how 4. You can delete 8. Okay, we can delete 8 entirely, and one occurrence of 2. Okay, if one occurrence of 2 is removed, then 2 is fixed, right? If 8 is entirely removed, then 8 is also fixed, right? And insert 5 twice. 2 times 5 if we add, then 5 will be also fixed. So resulting array would be 1 2 2 5 5 5. So it is like 2 removals and 2 insertions. That's why it should return 4. Okay, 4 moves, minimum moves. What do we have here in this function? 1 1 1 1. So there is 1 3 times more. 3 is just 2 times, and 4 is 1 time extra, right? Your function should return 5. How 5? 3 times 1 should be removed. To fix this, 1 3 we can add 4 moves, and 1 4 removed from here, 5 moves, right? And given if all tens, to complete this, either we can add 7 times 10 more, so that it will be 10 times 10, that will be 7 moves, or you can remove all 3 tens. This will be 3 moves and all will be fixed. Okay, right? An effective algorithm. Okay, let's work on this. Let's try to work on this. Okay, I'll tell you how I got a solution to this problem, or how one should approach in order to get a solution to any such kind of problems. Okay, so let's just focus on what we have as an input, or what we can at get as what information we can extract from given inputs, right? Based on the information, sometimes we find the logic how we can actually get a solution. Okay, so I tried this way. I mean, I was not getting a solution at the very first, but when I tried to deduce the information that I can get from this, I was able to get a solution to this. Okay, I'll write in the same way. So it's like, what we will have, we will have, say, take example of this array only, first one, right? This will help us to understand. Say our array is, I hope this should be visible. Say the array is equal to, right? So what information we can get is digits, right? What all digits it has, unique digits. It has 1, it has 3, it has a 4, right? So what all unique digits it has, we can get that information, right? Easily. We need, definitely need. And to fix this problem, like occurrence of each, we need to fix it for each unique digit present, right? If there is something like 1 is present, we definitely have to fix 1. Either we make the count as 1, or we entirely remove 1, right? And similarly 3, either we can add 2 times 3 more, or we entirely remove 3, right? Same for 4. So, I mean, this is coming as a logic, like in order to get these digits individually fixed, what we can do, two operations only. Either we can remove something to get that fixed, or we can add some more to fix, right? These are the moves that we can make. So let's just try to get two informations, that what is required, to make this zero. Okay, counter to make zero occurrence. Okay, or what information we get first? Let's say occurrence. What is the occurrence, right? Let's One is occurring two times, right? This is the first information. Three is occurring one times, four is occurring three times. Okay, now we can give counter to counter to complete, right? Counter to complete, that what we can add in order to get this completed, right? Getting a question like, say for 4, what more we need to add, how many times we need to add to complete this. So it is already present 3 times. To make it 4, we need to add 1 time, right? 3 is present 1 time, we need to add 2 more times to make it complete, right? 1 is already present more than 1 time, right? So we need to add some negative value, or we need to make add -1 in order to get this done, right? Definitely. Or this is fixing with completion. What to do to fix with 0? Count. Okay, count. Counter, right? Counter value to, or I can say counter value to complete. Counter, now we will have counter value to remove entirely, right? There can be two solutions only: either add some values to get this fixed to the count as same as that of digit, or entirely remove this, right? So one is present two times, like this is exactly clear. I mean, we need not to extract it separately. In order to remove, we just need the number of occurrences, only that, on that many times we need to remove. Say we need to remove 1, we need to remove it 2 times, right? So this is same as the occurrence of the digit. If we need to remove 3, we need to remove 1 time. And if we need to remove 4, which is present 3 times, we need to remove 3 times, right? Okay, so our question or our solution should be designed to make minimum number of moves, right? We need, so from here we got all the inputs. It is clear that we need to fix all the digits that are present. Either we fix with completely removing them, or either we fix by making their count of same as that of that digit, right? So we have got two types of solution. These are actually number of moves that needed to be made, right? To fix one, if we fix by completion, we need to make one move. Just we need to ignore -1, like -1, because even if we decrease something or increase something, that will be one move as chapter, right? For so in order to remove or complete one, we need to decrease one. I mean, decrease one position, one occurrence, right? In order to fix 3 as completed, we need to add 3 two times, right? In order to fix 4, we need to add just one more time. But in case of removal, to fix one, what we need is, in case of completely remove, we need to make two moves. Two times we need to remove. To fix 3 as removal, we need to make just one move. To fix 4, we need to make three moves. Three times we need to remove. So this is giving us a solution. Like there are only two solutions possible, either complete or either remove. And we need to fix it for each and every digit, right? So what we need to decide is the minimum number for each minimum number of moves to fix each digit. So okay, in order to say, for example, in order to fix one, either I can make a move to delete one, or either I can make two moves to delete one entirely. So one move is the minimum number of moves for to fix one. We will just remove one times. What about 3? Either we add 3 two times, or remove 3 one time to fix this. So minimum number of move will be 1, right? And now for 4, if we need to complete it, we can add one more 4, or if to remove 4 entirely, we can make 3 moves which is greater than 1. So minimum move become 1. So this will be our fix. To fix 1, we will remove this one time, right? Selection. We will remove one time. To fix 3, what we will do? We will remove 3 entirely. We'll just remove 3 one time, so it will be removed entirely, right? Fixed. To fix 4, we will add 4 one times rather than removing 4 three times. So This is how it becomes the minimum number of moves are selected, right? So this gets us to a solution to solve this problem. Let's try to see how we can write a Java code for this. I'll write a new class. This is our existing project. I'll write a new class. Minimum number of moves to fix array. Okay. This would be our class. I hope the code is visible enough. I'll increase size a little bit more. Yeah, this is fine, I guess. Yeah, right. So let's just try writing the code. We'll write the main method directly. Okay, main method takes array of string as argument, right? This becomes our main method, right? I'll write some comments. Main method. Okay. What we need is we would have an input of array, integer array, that would be say arr, or okay, equal to, let's just define this with the same values. We'll try the solution for all the values given, but let's just for now have these values. So we know that we need to get answer as 3. 3 are the minimum moves for this, right? And we will, this will be our input, right? We will make a call to a method, now solution, call to solution method, right? What would you call? Say we will try to get, we need to get an integer output, right? Minimum moves, right? This should be equal to get, we will name this method as get minimum moves. Okay, and this will accept integer array arr as input, right? Definitely it will give me stating that it is not defined, so we will define this. Okay, this is the method that we will call, and we will print the result. Okay, and number of moves to fix, let's just name this arr1. We will try it for every given solution. To fix arr1 array1. Okay, we will print as number of moves. Okay, this would be printed. Now let's just define this method. This will be the main method for solution. Again, this need to be public. We need to make it static, so because main method is using it, which is static in form. It will return me an integer, right? Name should be same as we have given here, get minimum moves, and this will accept an integer array as input, right? This becomes our method. Okay, so the above line is fixed now. It is just stating that add a return statement. Let's add a dummy return statement for now. We definitely have to add a return minimum moves. Okay, so to get this, let's just try to get this information first. Definitely we would need the information in order to get to a solution, definitely, right? So to get this, what we can do, we can store this information as a map. How we will do that? I'll define map of integer, comma integer, right? What this map would contains the digit and its number of occurrence, right? Map integer is equal to, say, we need to name it like number of occurrences, right, is equal to new, say, let's just create a hash map of integer, comma integer, right? This is the way we define maps. If not known, please do read about this, that how we define map or hash map, right? Okay. Get count, get digit versus count, right? How we will get, we would have to definitely have to move in a for loop so that we traverse the entire array and get this, right? So for that I will use integer I, we will traverse array arr. Okay, and while traversing, what we will do, we will see if e dot contains key. If this has key I, already has key I, then we will increase the existing count as 1 dot put, we'll put in value. What value we will put? We will put I versus we will increase the count by 1. So it is like it should be dot get object key should be I, will add 1 and we will store this. Okay, what we are doing, if this map already contains the value that we are traversing, so it's like 1 is present one time, right? Or when it comes second times, it will increase the existing count by 1, how many times you got. If that the element I, the digit I is not already present, so this is the first occurrence, then what we will do, we will just add this worth of occurrence dot put I will add count as 1, right? Because it is coming the first for the first time. If it comes second time, then this map would already contain this. Since this is not present already, that means it is coming first time, so we are getting hard count as 1 against that. Okay, this way we will get to see, this way we will get to see that um, this way we will get to see that how unique digits versus their number of occurrences. Okay, let me just try to print out. We'll see that are we getting this correct or not. Okay, sys out, what we will sys out, number of occurrences. Okay, I will okay, run this method. This won't I mean, this will gives minimum moves as 0 because we are returning hard 0 here, but we are more interested in this. Okay, saving this, running. Okay, so it is giving me, it is storing a map like this. So 1 is the digit, how many times it is present? 2 times. Digit is 3, how many times it is present? 1 time. Digit is 4, how many times it is present? 3 times, right? Exactly same. 1 2 time, 3 1 time, and 4 3 times. So far it is good. So we got two informations for now. What is the number of occurrences, and counter value to remove will be same. So wherever we need counter value to remove entirely, we will use this exactly, because to remove something entirely, you need to remove the number of occurrences it has, right? So we have got two inputs in one shot. Now what we need is the count to complete, the number of moves to complete, right? So for that, what we will do, we'll also, I mean, we need to return the minimum number of moves as well, right? So let's just define a variable to store that. It's like minimum moves, okay, equal to 0 firstly, right? And we will traverse this map for all the values, and we'll see that for each value, what is the minimum number of moves to complete, right? This is what we need to find. So for that, what I will do, I will we'll have to make a for loop again to traverse this map, right? Like number of occurrences, right? For that, I will write map dot entry attribute. This is an integer versus integer integer map. Say I call it. We got the entry sets. We got it set, and for that, what we'll get, number of occurrences. We'll get set out of this, and we'll traverse that set. Get no, the method is entry set. Entry set, yeah. So we got the entry set of this. We will traverse over that set. Okay. So we can, yeah. Now to firstly, what we'll take, count to complete, right? This is what we are trying to find. Initially, I took at 0. Okay. Now there can be three types of cases, right? For any digit can be present exactly the number of times it is required, right? or it can be present more than the number of times it is required, or it can be present less than the number of times it required, right? These three cases can be there. So if that digit is exactly same as that of number of times that it is, I mean, it is, if it is exactly same as that of number of occurrences it has, say for example, if one would have already present one time only, then we would not need to fix this out, right? Then this would become zero, right? So we'll write case for that. We can write just one case, but I'll write few cases so that we get exact idea. So I'm writing if what we need is set, yeah, right, set dot key. What would be the set dot key? It is 1 for the first time. If set dot key is equal to set dot value, right? That means in this map we have this like key and value are equal. Say 1 is present 1 times. If that would have been the case, this would fall into this, right? In this case, we will keep this as 0. But as you can see, since we are adding, I mean already taking this as 0, we don't need this code. This would be extra line of code. But I'm writing this for here, okay? What can be the other case? If set dot key is greater than set dot value. What does that mean? The the key is greater than set of values. What is this case? We don't have it. Yeah, we have case for 1. Key is 1, value is 2, right? So in this case, its occurrence is more than the digit itself. It should be present one time only. So that's why it is like, I'm sorry, this is the reverse case. The key is more than number of values. Key is more than number of values itself. We don't have a case here, right? So let's just write. I mean, if this would have been the case, what we would do? We would need to take the moves. I mean, say for example, I'm making a dummy case right now. Okay, what if key is greater than number of values? Yeah, we have this case, no? 4 is present. 4, which is the key, is greater than the values. Number of values is 3, right? This is the case. Yeah, this example has all the cases. 1 that has more number of values, 3 has less number of values, 4 is also having less number of values. So it's like key is less than number of values. What is sorry, key is greater than number of values. Key is 4, number of values is 3. So in that case, what we need to do is we need to get uh, count to complete would become, what would be the count to complete? It would be number of keys minus number of values. Okay, definitely. So what would this give? So every digit has same number of values. 4 should present 4 times. But here in this case, number of the key value, which is 4, is greater than the values. Value itself. What is the value? Number of occurrences, which is 3. So in that case, what we are doing, minus key minus value. 4 minus, that is 4 minus 3, which will result in 1. Okay, so count to complete will become 1. What would be the other case? Else, oh, sorry, we need to write else if here. Else if we don't need to write any else condition, but here, but still I would write in this way. Okay, what it can be like, key dots key is less than number of values, right? The key itself is less than number of values, which is the case for 1. So 1 is like, what would be the key here? 1. Number of occurrences, value, that is 2. So key is less than value. In that case, count to complete would become, count would key to become reverse of this. Get value minus get set keys, right? Okay, this would give us count to complete. So for each digit, we will get a count to complete in this way, right? And what we can do is minimum, we can add this count to complete to minimum number of moves for each, right? So it is like the final step. For one, we got the minimum count, which is, no, I'm sorry. What we need to do is we need to now compare the count of complete. Okay. What would be the count to complete? It should be minimum of two. We got this value, number of occurrences. We got number of values to remove, which is same as number of occurrences. Now we have got count to complete as well. The moves that we need to make to complete. We need to find which is the less value out of it, right? 2 or 1, 1 is the less. 2 or 1, 1 is the less. 3 or 1, 1 is the less, right? To compare this, what we will do, we will compare count to complete with if count to complete is greater than the value, right? If count to complete is greater than the number of values, then what we can do is we can replace count to complete with number of values. That means we can entirely remove in this case. We don't need to complete. Okay, this is the case. Check if count to complete is greater than count to remove entirely. Okay, so this will give us a final count to complete, right? Number of moves. We will add that to number of moves. Keep on adding. So for say for example for one value we got minimum number of moves to make one. We will keep on adding that to a variable. For three in next occurrence in next recursion we will get a minimum count to fix three. That will be one. We will keep on adding that. This way I'm writing this code. Minimum number of moves earlier it was 0. We will write minimum number of moves plus count to complete, right? So or this is same as minimum number of moves is equal to minimum number of moves plus count to complete. One or the same thing, right? So at end we will return minimum number of moves. Let's just run this code and see what it is giving us. Minimum number of moves to fix array 1 is 6. It is returning. Let me see where exactly it is not taking that good. Count to complete. If count to complete is greater than uh, count to complete is greater than get value. Value is the number of occurrences. Then we need to replace it by count. Get number of values, right? Definitely. And if get keys number and values, then it is count should be 0. Okay. If get key is greater than values, then what we need is key minus value count to complete. If key is less than values, then we need to value minus get key. And if count to complete is greater than this, then we need to replace it with this. Okay, I'm really sorry. We have written this two times. That's why it is adding everything two times. Either we need to use this one or one for while explaining, but I added that for explaining, but it should not be present this way. So moves. So this is one of the same code, right? So now let's just run this. There is no error in this code, right? So minimum number of moves to fix array 1 is 3. We are getting a right answer here, right? But we can still optimize our code because this is something that we do not need. It is already 0. If this condition becomes true, then this is already set 0. Other conditions won't become true, and this won't fall into under this, and it will remain 0 till this, right? So let's just remove this one, okay? And we'll have to make this as if statement. Now you can see in either ways, if I'm making get key minus get value or get value minus get key, right? So what we can do is we can just to get count complete, we can get an absolute value to this, right? What we can do, we can just simply write count to complete. Count to complete is equal to math dot absolute value we will get out of this, okay? We can either get keys minus value or right. key minus value or value minus key. If that is a negative value, it will return, make it that positive and return. If that is a positive value, it will return a positive value. Why so? It's like because even if for a case like one where in order to complete, still we have to remove, then it, but removing is also a move. If we add minus one, it will remove, it will decrease the count of moves, but we need this as a positive value because even removing a value is one move or adding a value is one move. That's why we are taking absolute value. So this code entirely need not to be there if an else statement. But yeah, this statement needs to be there. We need to check if count to complete is less than the number of occurrences itself, right? So let's just run this again. Saving this, minimum number of count is 3, right? Let's just quickly test this for other set of arrays as well. I will write like array, right? We have, there are a number of examples given in this. Let's just take two more example, array 2, array 3, right? We won't print this, we will, what we will print, we will print this directly. I'm calling method here. Here are 2, here are 3. Okay, let's just take two more array examples from the question itself that we had. I'll take this one, answer should be 4, right? And I'll take this one, answer should be 5. Okay, let's just take one more. There is these many examples only. Let's just take one more. So we will be solving all 4 of this. And it is 10 10 10, right? So let us run. So this is for array 1, array 2, array 3, array 4. Okay, this is a fill minute. I'm running this. So right, the code is returning for first we need 3 moves, right? 3 moves. To fix this, minimum number of moves is 4. To fix this, it should be minimum number of occurrence can be 4. Okay, this is same for this minimum return. It should return 5, right? And to fix this one, we should return 3. Okay. So this is a solution code for this. I'll add this solution code um, to the description of this video. If you do find any mistake or any better solution to this, please do write if you in the comment section. If you do not understand any step out of this, please do write, mention this in the comments. I'll try to explain within the comments, or maybe in the next video I'll try to make that better so that uh, you'll be able to understand the problems better. Thanks for watching this video. Please do keep following us for more such videos. We'll keep on adding, and please be active in the comment sections if you do need any explanation or if you do find any better solution to this. We'd be happy to learn that as well. Thanks for watching again. Great day.